Hi everyone, welcome back to Mr. Edmondo's channel. This is Jan 2026 P4 walkthrough. Please don't forget to subscribe, like, share the content, leave a message for me if you need more clarification, or let me know what you need me to cover in the next video. Thank you. Question 6, we have line L1. I've tried to draw the line L1 so that I can visualize it. Line L1 is this line over here. Now, this line L1 has a point P. The point P lies on L1. Point P, I'll say maybe my point P is here. I'll put point P to be there. And the point P is such that, so they said given that this point P is the closest from the origin, is the nearest from the origin. If the origin is here, this is my origin. And if point P is across the origin, it means that the line connecting the vector OP and the line, they are perpendicular. Since P is the closest to the origin, it will only be the perpendicular distance. OP with the perpendicular distance. That means OP, the vector OP, is perpendicular to the line. The vector OP is perpendicular to the line since point P is the nearest to the origin. So the vector OP is perpendicular to the line. That means when we dot the vector OP, we dot it with the line. But remember, if you're going to dot it with the line, you're going to dot it with the direction vector of the line, or the direction of the line. That means, but our vector OP, if P is any point on the line that we don't know, X, Y, Z, it means the vector OP is going to be X, Y, Z. We are going to dot that vector with the direction of the line, which is 2, 1, minus 3, and our answer will be 0. So when we dot it, we have 2x plus y minus 3z is equal to what? Is equal to 0. That's the concept of the nearest point is always perpendicular. But now the other thing we need to remember here is that the point P is on the line. So it has to satisfy this condition, the condition that says that x is equal to that, y is equal to that, and then z is equal to that. That means x is 3 plus 2 lambda, y is just a 0 plus lambda, and then z is 5 minus 3 lambda, and this should be equal to 0. So when you solve for lambda here, you see that your lambda is equal to 3 over what? 3 over 2. That means at P, lambda is equal to 3 over what? 3 over 2. Now all we need to do is to get this lambda here, which is 3 over 2, and substitute here to get your x, y, and z. Lambda is 3 over 2. Substitute inside there, you see that your P value is going to be 0, 3 over 2, and 1 over 2. You can press a calculator and see you get these values here. That's how we do part A. Part B of the question, I've tried to draw it over here. Now, what you're saying here, part B says that with respect to the same fixed point O, the line L2, as this equation. Now, when you see this equation, this is always the point on the line, and you can see for this line L2, it actually passes through the origin. That means I've drawn my line 2 over there. That's line L2. And what they've told us here is that the L2 meet L1 at which point? At point Q. That's when they intersect at point Q. So I've indicated this at the point of what? As a point of intersection. Now, that's the information that they have given us. So they intersect. Now, the first question is find the value of what? Find the value of A. Now, the thing is, if these two lines intersect at one point, the x, y, z over here in the first one is the same as the x, y, z in the second line. So it means that if they intersect, the x's are the same and also the y's are the same. I already some of this writing here because there are going to be so many. They're going to be the same. So what do we do here? So that means the x in the first line, is going to be minus 3 plus 2 lambda. This is equal to the x in the second line, which is 0 plus 4 mu. And the y in the first equation, which is just lambda, is equal to the y here, which is equal to just mu what? Mu A. the z in the first equation, which is 5 minus 3 lambda, is equal to the z in the second equation, which is just minus what? Minus 2 mu. So all we need to do is to calculate this equation to find the value of lambda and the value of mu at which they are equal. Now, you can see this one as the unknown, the area we're looking for. So we first leave this for a moment, then we focus on these two over here. Now, the first one, I move the constants on one side. So I have 2 lambda minus 4 mu is equal to 3. And then here I have minus 3 lambda plus 2 mu is equal to minus 5. So these one two simultaneous equation. What you're going to do, you just have to solve this simultaneous equation and then get the value of lambda and the value of mu. You're going to find out that, as I told you, you can put this on the calculator. You're going to find that lambda is 7 over 4 and mu is 1 over 8. These are the value of lambda and mu at which point? At point Q, where the two lines intersect. And now, if there's a value of lambda and mu, it means that they should also satisfy this equation that we left here. That means my lambda is 7 over 4 is equal to mu, which is 1 over 8a. Then you can see that the value of a is 7 over 4 divided by 1 over a. The value of a is 14. That's the value of a. Part C of the equation, part C of the question is this continuation of what we have done in part B, because they said Q is a point of intersection. But we've just found out that lambda is 7 over 4 and mu is 1 over 8. At that point of intersection, at point Q, the value of lambda is that and the value of mu is that. So it means I can either use this equation or use this equation. But I should use this equation because it has 0 here. So that means our point Q is a point whereby x is equal to, this is 4 mu. Actually, I'm just substituting mu over here. So at Q, the point, so x is 4 times mu, or mu is 1 over 8. Y is mu times what? 1 over 8 times what? Times a. 1 over 8 times a. And then z is just 1 over 8 times what? Times minus what? Minus 2. So you end up with your Q as 1 over 2, 7 over 4, and minus 1 over 4. You can use the first line, but the second line is better. That's your answer.